there, we can find little tiny galaxies. And the smallest of them now have literally only a few hundred stars in them.
The final
They've
frontier.
got something the size of a small star cluster that you can see by eye, so the size of the Pleiades. And yet it's an entire galaxy in its own right. So it's got as many stars in it as the Pleiades, but it weighs tens of millions of times more. Because what it is a big dark matter blob.
The blob.
Matter in the universe. So
Dark matter.
do you know about it, Chris?
Well, very little. All we know is that it interacts with the rest of the universe via gravity. Jerry?
Gravity.
What else can we say?
That's correct. We know nothing about it except that it's transparent and that it makes up most of the weight.
Dark matter simulation.
5 times more of this stuff in the universe than the stuff we're made of. And it's incredibly transparent. Actually, we're rather lucky it's transparent, because otherwise we couldn't see very much of the universe, because there's such a lot of it out there. And one of the great mysteries is, what is this stuff?
There is a third rather nice star in our local group, and that's the M33, triangle star.
It's been rather left out, hasn't it? What do we know about M33, Jenny?
So M33, as Patrick said, is also a spiral galaxy, but it's a dwarf spiral. It's much smaller than both Andromeda and the Milky Way. And it looks like it's a satellite companion of M31, which means that it orbits M31.
Does it?
Yes, we think so.
Controversial. Because the M33 has been thought of in the past as being an isolated and rather lonely thing.
That's right. It didn't have any tidal streams, for example. It looked very calm. And
space is a big, vast place, man. It's like infinite.
See now that there are signs of tidal interactions.
Both
so we're seeing streams
exterior and
so on
interior.
Tidally disrupted.
Well, there's a basic
Physics,
difference. Jerry, thank you very much. Well, you talked about the launch of the tank and Herschel probe. They went up from French Guiana. I think most impressive, and Chris was there.
Yeah, and
the
apparently...
spaceport here in Kourou has been home to the European Space Agency's launches for the last 30 years.
It's Guyana, French Guyana, there's Dutch Guyana, Suriname, and there's ex-British Guyana, which is Guyana. Anyway, apparently this Herschel and Planck telescope went up there, and apparently I was looking at I was looking on the web, above Top Secret or something, and they said that the fucking scientists monitoring these telescopes, they've got objects flying around them. Yeah, they don't know what they are.
On Herschel for more than 20 years. Watching it head out to the launch pad this morning, how do you feel?
It's actually a very funny feeling. I mean, it's like the kids leaving home. You know they go, but you don't realize up to the point they're gone. And for the kids, you see them back after some time. Herschel Planck we will never see back.
Are you nervous about the launch?
Yes, sure. I'm nervous, not really, but excited, because it's something you do once in your life. I mean, it's something you will never do again, and therefore excited, yes.
Planck and Herschel
To infinity and beyond!
spacecraft that ESA has ever built. They may be travelling into space together, but they have very different missions.
Which is?
What's Herschel's main mission?
Its main mission is to study the infrared universe. In fact, the far infrared universe from the millimeter universe. What this means is it studies the matter between the stars, which is cold, and this is the matter from which we
a big fucking space, man.
New planets, and we do that in our own galaxy, but also in galaxies far away from us. And in this way, we study how stars history.
So you see galaxies forming as well as individual stars.
Yeah,
big space, man.
So Planck's mission is to study the cosmic microwave background, the CMB. What on earth is it?
The cosmic microwave background, the CMB,
is left over from the Big Bang.
Photons, like what we call them, that last interacted with anything in the universe about 300,000 or 400,000 years after the Big Bang. The early universe, when it was hot and denser than it is today, was opaque to photons, to light. And then all of a sudden, at this time, about 400 or 300,000 years after the Big Bang, the universe went from being opaque to being transparent. So all of these photons that were trapped all of a sudden got freed. This is just like looking at the surface of the cloud. The photons are bouncing around inside the cloud, and then eventually they get freed. And so by looking at the surface of the CMB, it's like looking at the surface of a cloud, and you can see the structure of a cloud, just like you can see the structure of the microwave background.
It's like
so
fucking
much
Genesis,
gone into it already. I have to say, you seem very calm.
Seriously, it's like Genesis, you know, there was the darkness, and then upon the waters, let there be light. Boff.
worry because you know that the people who designed it and the people who operate it are experts at that kind of thing. So I'm putting my trust in the real rocket scientists who've put this system together.
We're literally a couple of minutes away now. The final preparations you can hear in the background being broadcast from the Launch Control Centre down
Guyana.
The final checks have been done, and so far it's been a flawless countdown. Having never seen one of these before, I'm sort of in awe of what we might feel and hear up here. We just have to wait and see.
Ignition, oui. Décollage. Look at that.
It's too bright to look at.
Star trekking across the universe on a Starship Enterprise and the Captain Kirk. Star trekking across the universe, only going forward, never in reverse.
We're waiting for the solid rocket ejection a couple of minutes in. Unbelievable sight reaching up from the launch pad.
Yeah,
That's the solid rocket ejection. There they go.
Further out they go.
That's the boosters
The
gone.
larger they see the space inside.
Well, there they go. 20 years of hard work, and Herschel and Planck are now on their way into space.
This is good shit, man.
So, how's it feel? Wow. Wow.
Oh, that was really good. I really enjoyed it. I decided to watch it rather than film it or photograph it. And it went off on the dot. The flames were spectacularly bright. A very impressive rumble.
24.5 minutes after launch, the rocket stops. 26 minutes after launch, Herschel separates. 28 minutes after launch, Planck separates.
That's fine.
38 minutes after launch, signal acquisition for
Centre
Herschel.
Spatial
9 minutes after launch,
Guyanaise.
signal acquisition for Planck. And I think at that point, we shall take off the photometer here. And that's it. Herschel's on its way, Planck's on its way, the Ariane 5 has done its job absolutely flawlessly. It's a stunning end to a...
It's funny that. They're exploring outer space from French Guyana, or Guyana, and I'm exploring inner space. And I'm from Guyana. But to explore inner space is to explore outer space and vice versa. There you go again, amigos. Paradox.
They lifted off just on time, as you saw, and everything's gone well since. Both Planck and Herschel are on their way to their final orbit. They're cooling down. The instrument startup has happened, and as far as we know, everything is absolutely perfect on both spacecraft.
Apart from the object.
That is great. Now, on to our other news notes, Chris, and we must always begin with the repair for the Hubble Space Telescope.
Yes, it's been an amazing few weeks for any astronomer because we had Herschel and Planck launch, and Hubble is now in the best shape it's ever been. The astronauts on board the scientists visited it, carried out a series of spacewalks, which did a whole series of things. Firstly, most importantly, they replaced Hubble's gyroscopes. These are the things which Hubble uses to point around the sky. Without them,
Will Robinson,
it has a full working set. The cosmic origin spectrograph that could look at galaxies in the early universe, and also the wide field and planetary cameras.
Wide field,
which will give us amazing views of pretty much everything. My personal favourite, they fixed an old instrument, STIS, which is an ultraviolet spectrograph. And the interesting thing here was they had to replace a part from inside the instrument that was never meant to be replaced in space. It involved undoing 120 little screws. They managed to do that perfectly. And as far as we can tell, we're still waiting for the first images, but everything worked brilliantly.
Well, time will tell. Chris, thank you very much. Now, next month, obviously, we're devoting it entirely to the anniversary of the first landing on the moon. How long ago that seems. So until then, good night.
The moon landings, yeah, I remember that. Yeah, hell. Good shit, eh? Space shit. Hmm.